and practice. Ladies and gentlemen, good afternoon. It's my great pleasure to participate in the 2018 Global Energy Interconnection Conference, and on behalf of SGCC, let me provide the following release. I'm going to talk about the innovation and practice of UHV AC and DC technology. UHV technology is a power transmission technology at 1000 kV AC and 800 kV DC. It enables transmission of bulk power over long distances with reduced losses, and is a strategic power technology upgrade and guarantee safe, economical, and green energy. Well, if for the onset of the UHV technology, the drivers for China to develop UHVs follow the geographical mismatch between energy resources and load centers in China. 80% of energy resources are located in the western and northern regions, while over 70% of the loads are concentrated in the eastern and central regions, which are 800 to 3,000 kilometers away. This indicates a strong demand for long-distance bulk power transmission. Well, the second driver is the ever-increasing power demand. Since 2000, the annual average growth of installed capacity is more than 80 million kilowatts, and the total electricity consumption has quadrupled. The third driver is that electric power development mode needs urgent change. The power sector of China has been relying on local balance for a long time, and the energy allocation is highly dependent on coal transport, which causes dozens of problems like a higher coal price and traffic jams. To solve these problems, we have to speed up the development of a power transmission system and build a comprehensive energy transport system. The fourth driver is the rapid development of the renewables. Wind power and solar power are characterized by intermittency and uncertainty and seasonality. And hydropower has seasonal and regional differences as well. The large-scale exploitation, efficient utilization of clean energy need the development of UHV technology and a large interconnected power grid. The fifth driver is the upgrade of a power grid technology. Existing 500 kV power grids face prominent problems such as insufficient transmission capacity, limited transmission corridor, and excessively high short-circuit current. All of these indicate the needs of raising transmission voltage, optimizing network structure, increasing efficiency, and ensuring operational safety and reliability. Second, development practice. Facing great innovation pressure and challenges, SGCC proposed a technology roadmap of fundamental research, engineering design, equipment R&D, experiments, verification, system integration, and demonstration projects, and achieved the technical breakthroughs and engineering application by gathering R&D resources in electric power and mechanical industries at home and abroad, and by industry academy research collaboration. Over the past 100 years, since there was electricity, China has been following other countries, and the application of 500 kV and 750 kV power grids lagged 22 years and 40 years respectively behind the developed nations. Obviously, it is a tough task to advance the leapfrog innovation. Sticking to independent innovation, SGCC has mobilized the resources to work on UHV technological innovation. The UHV technology embodies wisdom of thousands of scientists and engineers from China's main electric power research institutes, design institutes, and universities. Technical breakthroughs. SGCC solved many worldwide problems and made great breakthroughs in 6 core technologies, including UHV, electromagnetic environment, over voltage, secondary arc current and insulation coordination, helping China to stay ahead of the curve. And for 500 kV systems, the overvoltage is usually 2 pu and is still in the unsaturation range. With large capacity, long distance and complex electromagnetic environment, the overvoltage control is more challenging for UHV systems. It will enter the range of saturation even for overvoltage control to 2.0 pu, and the cost is unaffordable and the requirements for equipment are quite demanding, so great efforts must be made on overvoltage suppression. Then, through systematic study of the UHV electromagnetic transient characteristics and pattern, an innovative scheme is developed to suppress overvoltage with reactors, breakers, closing resistors, and MOAs. With the scheme, the overvoltage is suppressed from 2.0 to 1.7 pu, and the air gap is reduced by 3 m along the line, making UHV transmission possible in terms of technology, equipment, and economy. Well, the external insulation along surface of a solid insulating medium, the insulator surface is affected by the atmospheric environment. Severe atmospheric pollution will largely reduce the external insulation strength, and discharge may take place under normal working voltage in rainy and foggy days. It is a bottleneck constraint for external insulation dimensions and great challenge facing China's UHV technology. The mechanism of UHV external insulation discharge is mastered, and the new silicon rubber materials and large tonnage composite insulators are developed. As compared with the traditional porcelain and glass insulators, the pollution withstand voltage increased more than 1 time, solving the worldwide problem in external insulation design. And taking UHV AC transmission as an example, the tower weight reduced by 64%, cost cut down by 60%, out of 1.5 million RMB for every 1,000 kilometers line. UHV system failures are almost all single line-to-ground faults. UHV transmission lines are characterized by high voltage, long distance, and strong electromagnetic coupling. The secondary arc current caused by a single line-to-ground fault reaches 100 A around, and the arc cannot be self-extinguished. Based on the self-extinguishing theory of arc and the circuit parameter transformation theory, innovatively proposes the suppression of secondary arc current by neutral reactor of high resistance. The conductors of UHV links are featured by complex construction and large dimensions, and there are strong electric fields around conductors and serious electromagnetic interference induced by corona. Based on theory and experiment, the electromagnetic field distribution pattern of the complex multi-conductor system of a UHV links are analyzed on the basis of theories and experiments, and a complete set of prediction algorithms are developed and proven in practice. With the application of large section conductor bundles, the electromagnetic environment of UHV system is controlled to the KV systems, and the actual measurements are much lower than the limits specified. A full package of over 100 sets of UHV ACD1 categories is developed, which adopts new designs, new structures, processes, passes rigorous operation tests, and shows excellent performance, representing state-of-the-art technology of HV equipment manufacturing. During UHV DC R&D, only 5-inch thyristors were available at the time to meet the requirements for safety margin, economy, and innovation and development. 6-inch thyristors are developed, realizing leap forward technological progress. Key technologies in high voltage, large current, complex environment simulation, and real-time digital simulation are mastered, and a full-fledged research and testing system consisting of state-of-the-art UHV AC/DC test platforms is formed, laying a foundation for UHV development and continuous innovation in power technology. In terms of projects construction, UHV AC/DC pilot and demonstration projects have achieved a stable operation and satisfaction of these projects created a world record in the field of AC and DC power transmission, and has fully demonstrated the feasibility, safety, and environmental friendliness of UHV technology. The Jingdongnan to Jingmen 1000 kV UHV AC pilot and demonstration project has been in safe and stable operation for over 9 years. Since January 2009, accumulatively transferred 92 billion kilowatt hours of electricity. And the Xiangjiaba to Shanghai plus minus 800 kV UHV DC demonstration project has been in safe and stable operation for nearly 8 years since July 2010, accumulatively transmitting 185 billion kilowatt hours of electricity. The 4 AC and the 4 DC projects incorporated into the National Air Pollution Prevention and Control Action Plan have been completed. Total substation capacity 66 million kVA, converter capacity of 72 million kW, total length of 12,000 kilometers, adding 62 million kilowatts of capacity for west to east power transmission. The UHV backbone grid is under rapid development. SGCC has completed 8 AC and 10 DC projects, and the 4 AC and 1 DC projects are under construction. The UHV grid structure is preliminarily formed in North China and East China. 33,000 kilometers of UHV transmission lines are in operation or under construction, and 340 million kVA UHV substations and converter stations are in operation and or under construction. Also building the plus minus 1100 kV Zhangdong Wannan UHV DC project with a transmission distance of 3,324 kilometers and a rated capacity in kW is under construction, planned to be completed and put in operation this year. UHV AC/DC projects achieved high reliability in operation. The main equipment and systems have been operating well under full voltage, large capacity, and a variety of negative environmental conditions. The 3 Southwest hydropower UHV DC transmission projects operate for nearly 5 months during the flood season each year, showing high reliability significantly superior to conventional DC projects. 3 development achievements: the rollout and application of UHV technology plays an important role in promoting the optimized allocation of energy resources in a wide area, accelerating energy transmission and pollution treatment, improving grid security, and leading the upgrade of electrical equipment industry, which has brought significant social and economic benefits. It is providing international community with the China model and China plan. And a theme report of CIGRE points out that the breakthrough in key UHV technology and equipment is of great significance for promoting worldwide research and application of a UHV transmission technology. China's UHV project is a great technical achievement and an important milestone in the history of the world electric field. UHV AC transmission key technology, equipment, and engineering application won the special prize of National Science and Technology Progress Award. The plus minus 800 kV UHV DC transmission project won the special prize of National Science and Technology Progress Award in 2017.
Promoting energy resources to be optimized on a larger scale. In 2017, from west to east, 220 million kilowatt hour was passed, and 53% of them are UHV transmission capacity. We project by 2020 the UHV transmission capacity will reach 180 million kilowatt hour, and clean energy will reach 150 million kilowatt. Promoting construction of large-scale hydropower, wind and solar power stations in west of China. The 3 UHV DC transmission projects for delivering hydropower from southwestern part of China have reached 21.6 million kilowatt, which is equivalent to hydropower, and can deliver more than 100 billion kilowatt hour of electricity energy annually. the Hami, Zhenzhou, and Jiuquan Hunan UHV DC transmission line has an installed capacity of more than 10 million kilowatt class, promoting energy transition and upgrade. In 2017, UHV grid transferred a total of 249.6 billion kilowatt hour of electricity. Clean energy amounted to 161.5 billion kilowatt hour. The total installed capacity in China is 1,780 million kilowatt hour. 640 million kilowatt hour is renewable, which is percentage, which is an increase from 24.2% in 2010 to 36%. And the thermal power decreased from 73 to 62%. The wind and solar reached 106 million kilowatt and 130 million kilowatt, which is ranked top in the world. In 19 provinces, their renewable energy became the second largest power, treating air pollution, improving air quality in eastern part of China. UHV projects have transferred more than 940 billion kilowatt hour of accumulative electricity energy to eastern part of China, which is 10x Three Gorges hydropower station. Central and eastern part of China reduce SO2 and NOx by 280 million tons, and 390 million tons of coal are saved. The tariff of electricity transfer to east and mid part through UHV project is 0.049 RMB per kilowatt hour, cheaper than the benchmark feed-in tariff of local coal power in average. The UHV grids are featured with strong power flow transfer capability as well as voltage stability and can withstand major natural disasters and various severe faults. UHV grids reasonable distribution, districting operation of 500 kV grids is gradually achieved, thus effectively control the short-circuit current level. The state grid has been in safe operation for a long time and is capable of controlling large grid under stable operation. Driving comprehensive upgrade. The success of UHV technology in turn drives the comprehensive improvement of electrical equipment, enterprises R&D and design capability, manufacture capability, and testing capability. Contributing Chinese wisdom to the development of international standards. We issued 18 international standards, 137 national standards, and 214 enterprise standards. The IEC established 5 technical committees, including HVDC Transmission Technology Committee, UHV AC Transmission Technology Technical Committee. SGCC is the secretariat of the technical committee. Fourth, prospect. During the 13th five-year plan, we will speed up the contribution of North China, Central China, East China UHV synchronous grid, and further expand the scale of UHV synchronous grid during the 14th to further improve the nationwide resource allocation. Deepen the research on core grid technology. Large grid, including UHV, flexible DC, will be developed to meet the requirement of energy allocation optimization. As construction of a global energy interconnection with a global UHV AC and DC transmission technology will play a more important role in cross-border transcontinental grid interconnection and cope with world energy reform challenge. Lastly, we want to thank the conference for giving us an opportunity to exchange ideas. We will increase cooperation to commonly promote energy innovation, and so that we can contribute more to green, low carbon, and sustainable development of the world. Thank you.